So I want to talk about what we heard in the morning more in detail in the technical world. So how plasma treatment can help to get a globally sustainable printing industry. So my name is Peter van Steenacker. It's a Dutch name. And I've been in the plasma industry for 26 years now. And that's why I'm also called Plasma Peter or Plasma Pete. So the company Tigres is a quite small company. And what we do is we develop, we produce and sell atmospheric plasma systems. So what does that mean, plasma systems? We have different types of plasma systems in the market. And what we do is we have so-called plasma nozzles or plasma jets, as you can see on the left. And we also have corona systems. Corona systems are also a specific type of plasma, which is the older technology, to say so. All is referred to as atmospheric plasma. And the systems you can see here on the left of this edge is what is used mostly for print-to-shape treatment. So we print directly, or we treat directly on the objects which are printed on. Also known for a long time is corona treatment for film treatment, but that is where you treat on a film and then make a label out of it and put it on the object. So what is what we treat on? Here are some of the examples of the containers, for example, we treat before they are printed on. The materials we normally treat, or where our systems are used to treat, are polymers. This is roughly between 70% and 90% of all the applications we have are polymers. Also, we treat elastomers, metals and glass, and also some other fancy stuff like carbon fibers. And fun fact about glass, what most don't know is if you have a glass container you buy in the shop, a bottle or a perfume bottle or something, you have glass, but on top of the glass is a thin coating, a so-called cold end coating of polyethylene. So you print on a polymer. That's why glass also is treated. So what does the plasma do in the process? I distinguish between two separate areas, to say so. In the end, we don't know exactly what is doing the process because we don't analyze it. But one of the things the plasma does is it cleans the surface, mostly of organic contamination. A nice side effect, especially for digital printing, is that the plasma neutralizes static charge on top of the polymer, which can irritate or conflate or blow the small droplets of the inkjet to the sides. So that's a nice side effect. And what we also distinguish from that is the so-called activation. So we change the structure of the polyethylene or the polymers, and that gives an improved adhesion. That's the main goal of the treatment. And why this is important, we will see on the next slides. And also, the treatment gets oxygen in the surface of the polymer, and that increases the wettability of the process. And you can see what happens on those samples. When you treat the material, you see that the droplets, they get bigger, get better wettability, and you can see that the print is improved in how it looks. So you have this very black color instead of the grayish where it's not treated. So, why sustainability? When I use a word, I don't exactly know what it means. I like to look it up. So I had a look at Wikipedia, and I found that it means that it's the ability of people to coexist on Earth over a long time. So that's quite a nice goal, actually. And it also means the preservation of natural resources, again, to preserve human life on Earth. So that's a good start. So what are the problems? And I have 3 of the problems here on the screen. We have environmental pollution. This is very often forgotten nowadays because a lot of discussion is about CO2. But pollution is directly killing people, a lot of people. So this is also something I refer to on the next slides. This is, in my case, I address mostly the generation of electrical power with coal plants. And we also have something we don't discuss very much, but we have principal resource limitations. So sooner or later, it may be in 20 or 100 years, we will run out, or run low at least, on fossil fuels. That will happen, and I think it's a good idea to prepare in good time. So, what kind of advantages has plasma? One thing is, it makes it easier to make a material substitution. We can minimize the emissions of VOCs. It makes it easier to comply with REACH. We have the possibility to reduce air pollution due to lower energy consumption. And it's possible to completely run CO2 free if you have the energy source for it. It improves the recyclability. And now we will have a look on how this is happening, how this works. So one of the oldest things I have here is the history of plasma treatment, because that was the main reason actually to develop corona systems, was to substitute PVC with polyethylene. Because it's cheaper, in most cases at least, and it has a lot of advantages, and it's much more environmentally friendly. So they wanted to replace PVC with polyethylene. And the problem is that printing on polyethylene without treatment is almost impossible. So that's where the corona systems were installed in the machines many years ago, actually, from now. So it enables the use of polyolefins. And if you see look at this chart, you see here in this pyramid that polyethylene, for example, is a standard thermoplastic, which is very cheap, very easy to access, and most companies would like to use this material if they can and replace the more expensive ones. And good thing is that they are environmentally seen very nice to use. And all the materials on the left side are in general plasma treated due to their nature that they are semi-crystalline. So the next thing that happened on the market was the substitution of solvent-based inks with UV and water-based inks. And the demand of those inks is that you need a much higher quality of the surface of the material when it comes to adhesion and wettability. And this is where the plasma systems also are used. Most of the products you see here on the table, it's only a tiny fraction of what we do, are UV-based or water-based ink systems. Also, an important thing is REACH. REACH is giving problems because they ban certain substances, and that narrows the window in where inks and primers can be developed in. And when we do plasma treatment, we widen this window of possibilities with the inks and the materials to be used. So, also very interesting is the substitution of primers. This has been going on for many years actually. It's nothing new, but still it's very impressive to see the difference between primers and plasma treatment. So it's much easier in compliance when you use plasma instead of primers, because most primers are actually quite toxic, or at least most companies don't want to work with them for their employees' sake. Also, it improves the recyclability of the materials that are treated because no toxic substances is on the product. Especially those brands that produce smartphones are very, very much looking after those topics. A very big thing for us is, and for the customers, is that process automation with plasma is very simple. Because it's an electric process, I will come back to that, and this is very easy to monitor and to control in production. While putting a liquid primer on top of something is much more complicated, much more expensive to maintain. Oh, sorry, that was too fast. And if you have mass production, in most cases the plasma treatment is much much cheaper. As you can see here, for some examples, what the cost is of primers. If you have other numbers, just come to me and give them to me. I would like to have the numbers right here on this chart. I can calculate my way to this, but this I got from customers. But you can see the difference is staggering. So now we are looking at energy consumption. I have some emotional pictures for you here. And behind it is that plasma treatment in its core is an electrical discharge. So we have an electric system which can be monitored and controlled. And when we take for Germany, the typical CO2 emissions in Germany at the moment is 420 gram per kilowatt hour. But you could, if you have electricity which is made from renewable sources, run completely without CO2. And I made a comparison between flame treatment, which is very much used still in the treatment of glass, with, in this case, a corona system. And you can see that here the blue line is the CO2 emission over time from the flame treatment. The width is 100 millimeter. And the orange one is the corona system, so it's slightly lower, with those 420 gram of CO2 per kilowatt hour in Germany. And you see, obviously, here in yellow, that we have a flat line if you use energy or electric power from renewable sources. So then we have this really huge gap. But also costs are quite important, and if you look at gas treatment or flame treatment, you see that the costs go up quite extraordinary over time, while the corona treatment, due to its low amount of energy it uses, is quite flat. So over time, in many cases, the electrical treatment is much cheaper. So, a nice side effect of the electrical systems is that we can control and monitor and also adjust the plasma power. Oh, you had your fingers on, I couldn't see the time.
25 minutes ago.
Okay, good. So we can do a precise treatment. That means that the quality of the products can sustain at a very high level. And that means that scrap from production can be reduced tremendously, actually. For glass, for example, since they, in Italy, can't use the Russian gas anymore, they use it from Algeria. And the fluctuations in the gas quality is very high. So the quality of the burning of the flame went down, so they got problems in the quality. And another thing is that we can control our systems with so-called remote monitoring, which is possible because it's an electrical system. And nice COVID side effect, to say so, you have probably also experienced it, is the web meetings. So we could reduce travel time tremendously in the last 3 years. So I have reduced my personal traveling a lot. So this is what we use for remote service at our customer. We have those little devices. Our systems are fully computerized, so you can just plug this into our generators, put it to the internet, and then we can access the system and look what's going on and help the customer independently of where he is. It's done by some network system here. So the customer far away, for example, in California, in China, or in Australia, we can in real time change the systems to get it up and running again. Okay, conclusion. More sustainability is possible. We saw we are able to substitute the materials with a very easy system. We can save energy in comparison to other systems, and it can be operated completely CO2 neutral. We can help to save solvents. It enables the easy implementation of REACH. We can replace or optimize the use of primers. And it increases, in general, the production efficiency. And nice side effect, in some cases, up to 20% less inks can be used due to the better wettability, because the droplets, as we saw here, overlap. So this customer especially, they saved 20% of their inks due to the treatment. Thank you very much. I'm available for questions.
Thank you.